All right, let's dive right in. Maintaining the integrity of our systems can feel like a constant battle, can it? The secure baselines we work so hard to create, well, they depend entirely on having disciplined, systematic processes. Without them, we're really just waiting for something to go wrong. So today, we're going to build the playbook for winning that battle through some really solid configuration, change, and patch management.
First, we're going to unpack the unique threats that K-12 environments are up against. Then we'll walk through the disciplined life cycle of patching. After that, we'll see how to formalize change control to keep chaos at bay, and we'll look at the tools that make all of this actually sustainable. And finally, we'll see the big payoff, a network you can truly defend.
So, let's set the stage here. The challenge for those of us in K-12 IT is, well, it's unlike any other sector out there. And it's so important that we understand exactly why our approach has to be so rigorous.
This quote just hits the nail on the head. We're target-rich because, think about it, we hold a massive amount of sensitive data on students, staff, families, you name it. But we're often cyber-poor, which means we just don't have the budgets and resources of a big corporation. And the result? Attackers see us as low-hanging fruit, leading to this almost constant barrage of incidents. This isn't just a theory. For us, it's a daily reality.
Now, as big as those external threats are, one of our biggest enemies is actually internal, and it's sneaky. It's called configuration drift. The best way to think about it is like a slow erosion of your defenses. Every time a quick, undocumented change gets made to fix some small issue, the system drifts just a little bit further from its secure, stable starting point. And over time, all those little changes add up, creating the exact vulnerabilities that attackers love to exploit.
So how do we fight back? How do we deal with both external threats and that internal drift? Well, the first pillar of control is a disciplined, structured process for patch management. And this isn't about frantically applying updates whenever they pop up. It's about a repeatable, defensible lifecycle.
You see, the patch management lifecycle has 4 distinct phases that really form a continuous loop. It all kicks off with assessment, knowing what needs patching, and, just as important, why. Then comes testing, and this one's a big deal, because deploying a patch that breaks a critical application is its own special kind of disaster. Next up is deployment, a planned, scheduled rollout. And finally, verification, making sure the patch actually did what it was supposed to do and didn't cause any new problems. This isn't a one-and-done checklist. It's a constant cycle of vigilance.
Now let's dig a little deeper into that assessment phase because it is the absolute foundation of this whole cycle. You absolutely cannot protect what you don't know you have. It's that simple. That's why keeping a current asset inventory is totally non-negotiable. You should be using automated tools to discover everything on your network: servers, workstations, software, the whole shebang. Then you run vulnerability scans against that inventory to see what's missing, and, this is key, prioritize your efforts based on risk, because not all vulnerabilities are created equal.
What's so great about this is how it breaks down the practical, real-world steps. Before you even think about deploying, you have to have a verified rollback plan. Don't just assume you can undo it. Test the restore process so you know you can. During the deployment, schedule it for off-peak hours to keep disruptions to a minimum and document everything. And afterward, listen, the job isn't done. You have to keep monitoring the system to make sure that patch is behaving exactly like you expect it to.
Okay, this brings us to our second pillar of control. Patching takes care of the known vulnerabilities, but formal change control, that's what prevents us from creating new ones by accident. This is our #1 defense against configuration drift. The mechanism for this is something called a change control board, or CCB. Now, I know, that can sound super bureaucratic and slow, right? But try to think of the CCB not as a roadblock, but as a guardrail. It's a formal process that makes sure any major change is properly reviewed, understood, and planned for. It stops one well-intentioned person from making a quick ad hoc change that accidentally takes down a critical system.
And this right here shows you exactly what makes that process work: clear documentation. Every significant change request has to have these 3 things: a clear justification, why are we even doing this? A detailed impact analysis, who and what is this going to affect? And there it is again, a verified rollback procedure. This documentation turns a vague idea into a concrete, auditable, and much, much safer plan.
Okay, so we've got our processes for patching and for change control. But let's be real. In a typical K-12 district, you've got Windows, Mac OS, Chrome OS devices all over the place. Trying to do all of this manually? It's impossible. It's not sustainable. We need tools to make these processes actually work in the real world.
But before we even talk about tools, we have to remember this crucial point. Technology changes affect people. A patch that requires a reboot during class time or a system that suddenly behaves differently after an update can create some major friction. That's why the human side of this is every bit as important as the technical side.
So the key to making this whole thing work is really a combination of three things. First, automation. You've got to use centralized tools to deploy patches efficiently. Second, preparation, which we've talked about. Backups and rollback plans are a huge part of this. And third, communication. You have to let people know what's happening. A simple email notifying staff about a planned maintenance window can prevent dozens of help desk tickets and, more importantly, it builds trust.
So when we combine that disciplined patching cycle, formal change control, and smart automation, the result is a fundamental shift in our security posture. We finally get to move from being reactive and always putting out fires to being proactive. And here's the contrast, plain as day. On the left, that's the world of chaos. Undocumented changes lead to drift, which forces you into emergency patching, which creates even more instability. It's this vicious cycle of constant firefighting. But on the right, that's the world of control. You've got formal processes and planned life cycles that maintain your secure baselines, giving you long-term operational integrity. The difference isn't the technology, it's all about the discipline.
So if you take away just one thing from all of this, let it be this. Strict adherence to these formal processes is what stops configuration drift dead in its tracks. It's what lets us build and maintain a secure, stable, and reliable network that can actually support teaching and learning without constant interruptions.
And that leaves us with one final question to think about. As you go back to your day-to-day work, just consider this. What is the single greatest source of configuration drift in your district? Because identifying it is always the first step toward controlling it. Thanks for your time.